All right, so example two with this idea of inverses is to verify that f of x and g of x are inverses. So f of x is 4x plus 2 and g of x is 1/4 x minus 1/2. And so remember that if two things are inverses, they do the opposite. And so there is, informally, you could probably make the argument that these are, definitely inverses because pick a number, right? Pick any number. Let's just say we pick 3, and if you plug 3 into f, let's say f of 3, right? And then immediately, whatever you get for f of 3, if you plug that right into g, so let's see if we do that. If we plug 3 into f, we'd get 4 times 3 is 12, plus 2 is 14. Now, if I go over here and I plug in 14, so I plug in 14 here, I'd get 14 over 4, right? 14 fourths, which is 7 halves. So I'd have 7 halves minus 1/2, which is 6 halves, and that is right back to 3. So you could just make the argument here that, look, if I start with 3 and I plug it into f, and then I take that result and I plug it right back into g, I actually end up with the exact same thing. That's pretty much what an inverse is, right? You start and you end with the same thing. And that's a pretty good argument, right? The mathematical way to show this is that not just for a specific number 3, but for any x, for any number, this is going to happen. So if I take any number x and I plug it into f, and then immediately after I take that and I plug it into g, right? So from section 6.3, this looks like a function composition. If I take x, I plug it into f, and then I plug it into g, they would be inverses if I also get x. If we could show that for any number that this works, then that's kind of the definition. That's a good proof that these two things are indeed inverses. So there's actually a test here that I skipped over, the inverse functions test. So functions f and g are inverses of each other if and only if, and what we just showed there, I'm just going to write it again, but if I start with x and we do f of x and then we compose it, with g of x, if that equals x, right? And if I compose it the other way as well. So let's say I start with x, but this time I first plug it into g of x, and then immediately after that, I take that output and plug it into f of x. Well, if they're inverses of one another, you'll also get the same result. So if you're going to prove, like mathematically prove, that two things are indeed inverses of one another, these two things are always going to be true. So basically you would take two function compositions, or you take one function, you plug it into the other one, and you do it the other way as well, and you see if you just get x as your result. Then you know for a fact that they are inverses. So when you get problems like this that say verify that f of x and g of x are inverses, if we're going to do it mathematically and very, using that definition, we would go like this. We would say, well, let's check out what f of g of x is. And let's do that. What that means is I'm going to take g of x, right? G of x is this right here, 1/4 x. 1/4 x minus 1/2. And I'm going to plug it into f of x. I'm going to plug it into this x right here. So I'm going to compose these two things. So I'm going to say 4, and I'm going to plug in x there, but my new x is going to be that whole function, 1/4 x minus 1/2, and then I'll add 2. And then I'm going to take this side right here, and I'm going to go ahead and simplify it. And if I do that, so if I multiply this out, 4 times a fourth x is going to give me 1x minus 4 times a half is 2. And then I have this plus 2 that I bring down. And you can see that this is going to simplify just down to x. So my final statement here is just that. I just showed that f of g of x is equal to x. And that's one of the tests there. So we have to do it the other way as well. So not only do I have to do f of g of x, I have to do g of f of x. I'm going to say g of f of x, and I'm going to plug it in the other way too. So what this would show is now I look at what f of x is, which is 4x plus 2, and I'm going to take that and I'm going to plug it into g of x right here. So instead of 1/4 times the input minus 2, I have 1/4 times this new input minus 1/2. But the input now is 4x plus 2 because I'm plugging in f of x. So I do the same thing, and I'm just going to show that if I simplify this, now I should just get x. And you can see that I do. So 1/4 times 4x, that's 1x, 1/4 plus 2, well, I get plus a half, or 2/4, which is a half, and then minus 1/2 comes down, and this is indeed equal to x. So my final statement here would look like g of f of x, that equals x. So again, what we're saying here is if I start with x and I run it through these two functions back to back, I compose them, I show that for any number x, not even just a specific number, but for any number x, if I start with x, I am going to end with x as well. And it doesn't matter which way you go. So if I do g of x first and then plug it into f, or if I do f first and plug it into g, I'm starting with x and I'm ending with x. And so because those two conditions are true, and that you just showed, you just prove that these two things are definitely inverses. And so that's one way to do it. So when you see in your homework these types of questions where it says to verify that they're inverses, you have to simply show this work along through it. So they are inverses. All right, so here's one that you can practice. So you can pause here, and it says to determine whether each pair of functions are inverses of one another. So I want you to go ahead and test using that function composition test and see if these two things are indeed inverses or if they're not. All right, so to check if these two things are inverses, we're going to do the same. We're going to use that test that we just did up here. We're going to test if I do a function composition of those two functions, f and g, or whatever functions you have, that you would end up with x. If one of those two compositions doesn't work, or if both doesn't work, then they're not inverses. But if it does work, then they are. So what we'll try is a function composition. I'll just start with one of these, f of g of x. It doesn't really matter which one you start with. So that means I'm going to take g of x and I'm going to plug it into f of x. So f of x is 5 times an input minus 4. We're going to replace that input now with 0.2x plus 1. And now we're going to go ahead and simplify this. So 5 times 0.2 is going to be 1x. I have 5 times 1, so plus 5. And then I have a minus 4 here. And so if I reduce this, I get 1x. And this does not cancel. I have plus 5 minus 4. So this is going to be plus 1. And so I don't get what I started with. So this right here is my final statement right here. I have f of g of x equals 1x plus 1. So I'm starting with x, and my output is not x, it's x plus 1. So this automatically fails the test. This fails. So therefore, these are not inverses at all. So not inverses. And you don't have to check the other way at all, because if one of them fails, then they're definitely not inverses.